We're doing system of equations story problems today. So remember, systems are like two equations, and then we're going to combine them because they have two variables each, and we're going to mash it down to solve for one variable, and then we use that to figure out the other. So the sum of two numbers is 15, and their difference is 3. Find the numbers. We can set up whatever variables we want for these. But if you think back to the old days, when I say the sum of something, that means addition. So if I add these two mystery numbers, let's just call them x plus y, they have a sum of 15. If I take these same two numbers, and we don't know what they are, but it says the difference, that means subtraction. So if I did x minus y, it says their difference is 3. Holy cow, we got a system set up. Now, if you're a pro at elimination, which you probably are, remember you want your x's to line up or your y's to line up. You want one to be positive, one to be negative, because then you could go straight down with it. If you look here, we have the positive y and the negative y. Great, those will cancel out. So if we just add everything straight down, x plus x is 2x, y minus y is nothing, and then 15 plus 3 is 18. All we have left is 2x equals 18. How do you solve that? You divide by 2. And we get x equals 9. Now remember, we made up x. We're not looking for a coordinate necessarily. We're just looking for numbers that work in both equations. So 9 is one of our answers. To figure out the other, we'd have to substitute it back into one of the two equations. It doesn't matter which one. I always say look for which one looks easier. To me, that first one looks easier to work with. So it said x, which we already know is 9. 9 plus y equals 15. There's only one step there. To get rid of that 9, you would just have to subtract it from both sides. Minus 9, y equals 6. So again, we're not looking for a coordinate. We're just looking for the two numbers. They're 9 and 6. So number 1 says, what's the smaller number? That would be the 6. 2 is, what's the larger number? 9. Cool? That's one type of problem. And we have two more of those coming up. Ooh, this is where it gets tough though. 170 people were on a charter flight to Los Angeles. Some people paid $220 for their tickets, and some paid $280. If the total revenue for the flight was $40,400, then how many tickets of each type were sold? So here's what I like to set up when I'm doing these story problems. I like to set up two equations, one with the total number, and then another one with the total value. Now again, we can choose whatever letters we want here. Let's use A and B. So if I took the two different types of tickets, if I took all the tickets that were $280 or $220, and I add all the tickets that were $280, if I'm just doing total number of tickets, how many tickets were sold? 170. Now, look, I said that A was the $220 tickets, and I'm using B for our $280 tickets. So now if we assign a value for our second equation, each one of those A tickets, the company gets $220 for. So if we sold 10 tickets, you'd do 220 times 8. So we're going to set that up as 220A plus the other tickets were $280, 280B equals, and the total amount of money that was generated here was that $40,400. Okay, we got our two equations. We got to get them to match up now. So we can get away with just multiplying the top equation, and you could choose the A's or the B's to get to match up. I would choose the A's just because 220 is smaller than 280. But again, both would work. So to make A 220A, you would have to multiply by 220. But again, we do want one of these to be negative. So I'm going to multiply by negative 220. We have to do that to the entire equation. So that would give us, and I'm going to write it right underneath here, negative 220A. Negative 220 times B is negative 220B. And negative 220 times 170, I do not know what that is. Negative 220 times 170. Negative $37,400. Now if you look at what's left, we're able to do elimination because 220A minus 220A is no A. 280B minus 220B is 60B. And then 40,400 minus 37,400 is 3,000. So there's one step there. 60 times B, we're going to undo that with some division. We could shave off a 0 for a 0. 300 divided by 6 is 50. So B represented the $280 tickets. So for number 4, 50 people bought those $280 tickets. But we want to know how many also bought the $220 tickets. We have 3 equations to choose from here. Go with the easiest one. To me, that first one is by far the easiest. It's just A plus B equals 170, and we know that B is 50. So we're just going to say A plus 50 equals 170. How do you get rid of plus 50? You subtract 50, you silly goose. A equals 120. And again, 120, or A was the $220 ticket, so that means 120 people bought that ticket. Now you could check this if you had some extra time. Each one of these 120 tickets is $220, so you could multiply 120 times 220, and that would be $26,400. If you did $280 times each of those 50 tickets, that's $14,000. And then if you add those up, it's $40,400. What? Are you serious? It's almost too much fun. That's the second type of problem. And then this one, I think you guys would like the best, which is odd because to me these are the toughest ones. At Mr. Plant's garage sale, all books are one price and all magazines are another price. So we're dealing with books and magazines. We'll use the letters B and M. Harry bought 3 books and 5 magazines for $17.75. Oh, we did do a problem like this earlier. So again, we're going to do like a total number and a total value. Or we'll just do total values here. I don't know why I said I was going to do a total number. So Harry bought 3 books. If each book was $5 and he bought 3 of them, and I said, how much is that? You would do 3 times 5. So we're going to do 3 times however much a book is. Plus, he also bought 5 magazines. So we're going to do 5 times the price of a magazine, which we don't know yet. That total was $17.75. There's one equation. Sandy bought 2 books, to be or not to be. That was free. And 4 magazines plus 4M equals $13. You could just make it 13 or 13.00. Now again, we got to get these to match up. You could work on the books, you could work on the magazines. I'm just going to work on the books because they're smaller numbers. We need 3 and 2 to go into the same number. Easiest way you can do it is just flip-flop the numbers, or they go into 6. So that's 3 times 2, and that's 2 times 3. But we do want one of these to be negative. It doesn't matter which one. I'm going to make -2 there. So we're going to multiply this entire equation, and we're going to have to do it to both. So if I did -2 times 3b, it's -6b. -2 times 5m is -10m. And -2 times 1775 is -3550, I think. I'm going to check that. 1775 times 2. All right, 3550. If we hit this one with 3, 3 times 2b is 6b. 3 times 4m is 12m. And then 3 times $13 is $39. If you look, the books are going to cancel out now. 6b and -6b. For the magazines, we have negative 10 plus 12, or 12 minus 10. That's 2 magazines. And then negative 35.50 plus 39, or 39 minus 35.50, would be $3.50. So we have 2 magazines equals 35.50. We don't want to know the price of 2 magazines. We want each magazine. So we'll divide it by 2, which means a magazine is $1.75. Cost of magazine, $1.75. Now, how in the world could we find the cost of a book? Well, we have 4 equations that we can use. Use which one looks easiest. I'm going with the second one. That one. So we have 2 books plus 4 magazines. We already know how much each of those magazines are. They're $1.75. So we're going to do 4 times $1.75 equals $13. Great. So let's see. 4 times $1.75 is $7. So if we just clean up that part, we'll have 2b plus $7 equals $13. We know how to get rid of plus $7. You just subtract it. If you do it to one side, do it to the other side. 2 books equals $6. We got to divide it by 2. So each book comes out to $3. Fun. That was a true delight. Okay, all right. The sum of 2 numbers is 53. Their difference is 19. We've done these type of problems. It was the first one we started with. Sum addition. X plus y equals 53. Difference subtraction. X minus y equals 19. We already have the y's that are going to cancel out. So we can add straight down. X plus x is 2x. Y plus negative y, nothing. 53 plus 19 is 72. So if we go ahead and divide that by 2, we get one of our numbers is 36. I don't know if that's the larger number or the smaller number, but if I took this first equation and I put that in place of x, we'd have 36 plus y equals 53. What are we going to do with that 36? Yeah, we're going to go ahead and subtract it. Minus 36, y equals 17. So our numbers are 17 and 36. Which one's the smaller number? 17. Which one's the larger number? 36. Oh my goodness. That was fun. Let's try another one. We're back, baby. A total of 140 tickets were sold to the annual concert of students and non-students. Student tickets were 7, non-student tickets were 10. If the total revenue for the concert was $1,130, how many of each type of ticket were sold? So again, we're going to set up a total number of tickets and a total value of tickets. Total number, if I took the student tickets and I add the non-student tickets, how many tickets were sold? Well, 140. Now, if I was to assign a value to each of those tickets, each student ticket gives us $7, so we'll say 7S. Each non-student ticket, we get $10 plus 10N equals those 140 tickets. How much money did it generate? $1,130. Great. So now we got to get the S's or the N's to match up. I'm going to do the S's just because it's smaller than the 10N. So if we multiply this top one by 7, they'll both be 7S, but we want negative 7S. So let's multiply by negative 7. We're going to do that to all 3 of them. So we'd have negative 7S, negative 7N, and then negative 7 times 140 is negative 980. All right. So now if you look, the S is canceled. For the N's, we have 10 minus 7, that's 3N. And then 1130 minus 980 is 150. 3N equals 150. What do you do with the 3? We got to divide it. You got this. n equals 50. Now remember, n we use to represent our non-students. So that would be number 10 there. How in the world could we figure out the number of students, though? Look at that first equation, dude. We already know the non-student is 50. So our equation could be s plus 50 equals 140. How do you get rid of plus 50? Mr. Plan, we subtract 50. S equals 90. So there were 90 student tickets sold. That was tough. That was tough, man. Pause if you need to. If you need to get this down, pause it. But I gotta keep pushing. On Thursday, Josh bought coffee and donuts for the math department. What a sweetheart. We got coffee, we got donuts. We're gonna say C and D. He bought 12 donuts and 7 cups of coffee for $19.65. So if we were to 12 donuts, 12D. I also bought 7 cups of coffee plus 7C, and that cost $19.65. There's our first equation. The other one, on Friday, he bought coffee and donuts for the other teachers in his hallway. 9 donuts, 9D, plus 5 cups of coffee, 5C, and that was $14.55. We got to get either the donuts to match up or the coffee to match up. Remember, a backup option is you can always just take the numbers in front and flip them. However, you could do that with the 12 and 9. There's a smaller number because 12 times 9 is 108. And there's a smaller number that they both go into. They both go into 36. So that's 12 times 3. That's 9 times 4. But again, we do want one of them to be negative. So I'm going to make -4. So if I get that top line with 3, and I know I'm going quick here because this video is getting pretty long. So this line times 3 would give me 36D plus 21C equals 3 times 1965. Whoops, 3 times 1965 is 58.95. Now the second line times -4 would give us -36D minus 20C equals -4 times 1455 is -58.2, or since we're dealing with dollars and cents, we'll make it 58.20. All right, donuts canceled. Coffee is 21 minus 20 is 1C. Woo! 58.95 minus 58.20 just leaves us with 75 cents. So a cup of coffee, what a deal. 75 cents. We do have to figure out how much those donuts cost though. So we have, again, 4 options to work on. I'm going to choose the second one just because it's the smallest numbers. We have 9 donuts plus 5 cups of coffee, and we know that each coffee is 75 cents, and that came out to $14.55. We could do 5 times 0.75. It's $3.75. So we have 9 donuts plus $3.75 in coffee equals $14.55. You know darn well we're going to subtract that $3.75. That'll give us 9 donuts for 10.8 or $10.80. And then we'll go ahead and divide by 9. Your calculator will tell you it's 1.2, and that's true, but if we're talking dollars and cents, we're going to say that's $1.20 per donut. And again, you can check these by taking the value and substitute it in the original equation and make sure the price checks out. I think we got 2 more. Oh, 3 more. Darn. We're going to have to do these pretty quickly because I got another class here in a second. Sum of 2 numbers, x plus y. The sum is 1. Huh. The difference, x minus y, is 33. Okay, so again, the y's cancel out like they usually do on these. We have 2x no y's equals 34. If we go ahead and divide that by 2, one of our numbers is 17. We don't know the other number. So we could substitute that 17 for x. That would show 17 plus y equals 1. And then you would just subtract that 17. And the other number is negative 16. So our two numbers are 17 and negative 16. Which one's smaller? Obviously the negative. Don't be ridiculous. All right. There were twice as many tickets sold to children than adults for a summer movie. So we're dealing with children and adults. Now, it says there's twice as many kid tickets as adult tickets. If I said they sold 10 adult tickets, how many kid tickets did they sell? 20. Because you just took the adults and you multiplied it by 2. That's one of our equations. The number of child tickets is 2 times the number of adult tickets. What? One equation down. Now we're given the value. Ticket prices were $5 for children, so we could say 5C plus $8 for adults. 8 times the adults. The total revenue was $378. So if we're getting $5 per kid ticket plus $8 per adult ticket, it comes out to $378. Now we're going to use substitution. Huh? Remember that old thing? Anytime we see a C in the equation, we can substitute in 2A in its place. So here's the C. So we're going to substitute in 2A. And remember, the whole reason we do that is because we want it to be all the same variable, all the same letter. Now they're all A's. So 5 times 2A is 10A plus 8A equals 378. That would give us 18A, right? 10A plus 8A. 18A equals 378. If we divide by 18, 378 divided by 18, I don't know that offhand. 21. So there were 21 adult tickets sold. We do need to figure out the kids though. So, oh man, this equation's super easy. The number of children is 2 times the number of adults, and there were 21 adults. 2 times 21, 42 kids. Unbelievable. That was just too much fun. I'm almost sad that this is the last one. You guys know old Bill, right? He's always carrying around change in his pocket. Bill has 42 coins consisting of dimes and nickels. If the value of his coins is $3.65, find the number of dimes and nickels. So again, we're going to set up the total number and a total value. So the total number, if I take all his dimes and I add all his nickels, the total number of coins was 42 coins. Now we're going to throw values on those. How much is each dime worth? 10 cents. So we're going to go either all decimals or all whole numbers. So if you want to make it 10 times D, that's fine. The nickels, you'd make 5 times N, but the $3.65, we're going to have to go like in cents. So that we'd have to make that 365. I think that's almost more confusing. So I'm going to put the decimal values on these. So a dime is 10 cents. So 0.10 D plus the nickels are 5 cents each. So 0.05 times the number of nickels. And the total amount of his coins was $3.65. Now we need one of these to match up. I'm going to get the nickels to match up because I could just take this top equation, and if I want it to be 0.05 N instead of N, I could just multiply by 0.05. But remember, we want it to be negative 0.05. So let's go ahead and give everything this negative 0.05. So that'd be negative 0.05 D, negative 0.05 N, and negative 0.05 times 42 is negative 2.1, or negative $2.10. All right, we have 0.10 D minus 0.05 D. 10 cents minus 5 cents. It's like 0.05 D. The ends will cancel. $3.65 minus $2.10 would be $1.55. All we have to do now is divide by 0.05. And it gives us 31. There's 31 dimes. To figure out the nickels, we got to pick one of the equations. I'm going to pick the first one. This one's way easier. And we know that there's 31 dimes, so it would be 31 plus the number of nickels equals 42. Then your last step is just subtract that 31. And the number of nickels is 11. That was tough. A real doozy, but we did it.